And so you'll want to test it. To me, this testing step is really important, right? So if you pass inputs into your brute force recursion, it should give correct answers. Although possibly for large inputs, it may take a long time, right? To me, there's a big difference between code that is slow and code that is wrong, right? So here we should give back valid results, although maybe our code is a little slow. Then once we have our working brute force solution, making it efficient using memoization is a very, very canned scenario. All we do is start by adding a memo object into the mix. So this memo object needs to have keys which represent arguments to our function, and the values of that object represent the return values for those function calls. We know that in our functions, a unique set of arguments should give me a particular result. So we're just having that sort of mapping inside of an object. You need to make sure that this object is shared among all of your recursive calls. One way you can do that is to pass them along as arguments. And lately I've been doing that by giving myself a default empty object at the top of each of my recursive calls, right? Through my top level call. Once we do that, we need to add a new base case into our code. So I'm not going to remove any of the old base cases from my brute force solution. To me, I'm just adding a new base case that captures the memo. In other words, if my arguments are in the memo object as a key, then I'll return the stored value. I refer to that as like my memo fetching logic, right? Looking up some stored value in my memo. And beyond that, the only thing we need to do is implement our memo storing logic. And it's as simple as going to exactly where we had our return values in our function. And then we just make sure that we add those return values into our memo object before returning, right? So I always look to the exact return expression and just write some code around it, right? Storing that result into the memo object before I return it. Right? Step 2 is actually very, very easy to implement, meaning it's very easy to memoize a brute force solution. It's really coming up with the brute force in the first place that kind of feels more difficult. So as you're learning and practicing memoization for these dynamic programming problems, I highly, highly recommend you stay very methodical and follow these steps, right? Don't try to efficiently implement an algorithm from the get-go. Get a brute force working solution with recursion and then implement it using memoization afterwards, right? And as you get more practice with this technique, soon you'll be able to do everything all in one swoop, but I don't recommend that until you've definitely finished this course. So we'll be sure to follow these rules for our following problems. All right, so I think it's time to increase the difficulty and work on another dynamic programming problem. So let's work on this can sum function. What I need to do here is take in a target sum as an argument, as well as an array of numbers. My function needs to return a Boolean, so true or false, indicating whether or not it is possible to generate the target sum.
Estando con ella y pensando en ti. Given string S, return the longest palindromic substring. So what is palindromic? Oh, a string is palindromic if it reads straight forward and backwards. Qué tontos, qué locos. Nosotros sonándonos, qué tontos, qué locos. So, example 1, we have input of a string. Input of a string. And then output is the longest palindromic substring, which would be this. Right? Or these two. Let's do this. Or these two. And constraints. This consists of only digits and English letters. Okay, so first step we do is visualize the problem as a table. And so this, what we're trying to do is find the longest substring. And so the longest substring could be the size of the string itself. And so we would create a table that is create a table and the table is going to be let's say it's 1, 2, 3, 4, 5. The string is 5. And then we're gonna do something like this. 6 long. If you understand how you could easily take my man, but you don't know what he means to me, Jolene. We'll do 6 long. And we'll do 0. One, 2, 3, 4, 5. So if the string is this, this is the string. What we're gonna do so size the table based on the inputs. So again, it could be the whole string, right? Now we're gonna have to initialize the table default values. So if the default value is so let's say we have inputs of something that's like a not has no value, no longest substring, no longest anagram, or a value that has no string at all, something like that. Then we have the default. Default is default. Table 0 is equal to empty string. All right, so empty string is the default. Oh no, not table 0, just default is empty string. Default is equal to empty string. All right. Let's just do that. Default is empty string. And then the initial value is the next thing you do. See the initial value. So what would be the initial value? How do we do it here? So what we're going to do is we're going to say, okay, is the next string Hay algo que te guste de ti. Maybe we gotta see, okay, is the letter How do we iterate through the table and fill further positions based on the current position? Maybe we have to create these substrings. So we know it's a valid substring if the beginning is, if the last one is equal to the end. That's how we know. The first one is equal to the end. So the first part of the string is equal to the end. So is this a valid string substring? Yeah. So is A a valid substring? Let's see. Is A or like B a valid substring? Return us. Yeah. If that's a valid substring, then maybe the first default value, the first table value, should be the first letter of the string. Right? So trivial answer. Right? That's what's called the trivial answer. It's not going to be one value. Trivial answer is the S0. Trivial answer table 0 is equal to S0. default and trivial answer. So S0. And then once you add something, you loop through, or so starting at 0, you have this thing, and then you want to add it to the next index. Is it the next index string? I mean, so when we do it with something like this, you know, you're creating values that are not even like part of it, because you're like just saying, okay, if we were to do it, if we were to add 3 here, is that valid? Pretty much. So if we were to combine the first letter with the first, or is the default value also a string from this one? Empty string. Is default value also an empty string in this one? Let me see if I can. this. I don't know, like, what would be the default trivial, but I feel like it should be like A, B. I feel like it should be like start out with this, and then you go midnight like that. I feel before. I want to say the default trivial answer is also this. Maybe it's actually this. This is the default answer, and this is also the trivial answer. It has to be that, I think. And my friends and stuff like that. Making it so I'm breaking it off. Maybe I should lessen the table. So if I lessen, because we don't have an initial thing, because the constraint always has to be more than one, we should just lessen the table, maybe. Maybe for this one, we should just lessen the table. Let's try that. So like in this one, what I wanna do with you. I do what I do. I heard I was good. They wanna see if it's true. The one I wanna give it to. I can see you want me to. Yeah, I'm waiting. Think I will make a move now. Now I'm waiting. Think I wanna make a move. I'm gonna tell you if you like it. They heard I was good, they wanna see if it's true.
I actually don't change the values of those next two positions. So nothing really is calculated on that first iteration. But in any case, I can continue on to the next iteration. So my current position is always in yellow, and the next two positions are pointed to in blue. At this point, my current position says 1, so what I should do is take 1 and add it to both of my next positions. So that means 2 and 3, or indices 2 and 3, contain both a 1 and a 1, which so far makes some sense because at least for the 2, the second number of the Fibonacci sequence is indeed 1. And I can do the same thing, right? My current position contains position, and I'd be making this one a true now. Current is at index 3, so I need to grab words from the word bank that start with P and potentially have an L and an E. So I need something that starts with a B, right? Let's do one more problem together. Let's revisit that all construct problem. So we're still taking in our target string as well as an array of words in a word bank, but this time you want to return all of the ways that you could construct the target by concatenating elements of the word bank. So here you need to return a 2D array. That means a single element of the array represents one combination that makes the target. And like usual, we can reuse elements of the word bank as many times as we see fit. So if we take a look at an example, let's say I gave you the target of A, B, C, D, E, F, and I gave you this array of words. You actually have many ways to create the target string. There are 4 ways over here. So each subarray represents one combination, where if you concatenate it together,
So I would think you would do something like B. Want to bum. You want to chill with the big boys. Something like that. And then you would do the previous one plus the current thing. The previous one plus the current number. Is that how it is? Like this one? And just do everything? Because then if you go to here and you have like A, have like she want to bum. She want to chill with the big boys. Maybe it is like something like this. Unfreeze my love, looking at you, I don't need enough. This one's already like different because of the size of the table. infinity would be enough.
Indices 2 and 3 contain both a 1 and a 1, which so far makes some sense because at least for the 2, the second number of the Fibonacci sequence is indeed 1. And I can do the same thing, right? My current position contains a 1, so I'll add that 1 into my next 2 positions. Keep doing this. I add 2 to my next 2 positions, add 3 to my next 2 positions, I actually don't change the values of those next 2 positions. So nothing really is calculated on that first iteration. But in any case, I can continue on to the next iteration. So my
implement it using a tree. Let's implement it using a tree. So how would we implement it using a tree? We would do I don't even know how you would implement this. Maybe you would start at the middle and you say, is this start at the middle and you say, is this recursive? And you go, is this, or sorry, is this, is this palindromic? Is this palindromic? And then you go further. You say, is this palindromic? That's not really recursive.
BAD, and we want to return the longest palindromic substring that exists inside of here. In this case, there's actually two, BAB as well as ABA. So we could return either of these and that would be perfectly fine. Now, what actually is a palindromic substring in the first place? Basically, it means that, you take BAB, if we wrote that in the reverse order, which would be, BAB, it's the exact same string. So, like I usually do, let's say you just don't know how to solve the problem. Well, what's the most brute force way you could do it? Well, you could say, I'm just going to check every single substring in this original string and check if it's a palindrome and get the longest one. Starting at B, so I would check this, I could check this, I could check this, this, and this, right? So every substring containing this original B. And I want to check for each of these, is it a palindrome or not? And I would repeat that process with every character, right? So for this A, I'd get every substring and basically keep doing that. Now, the question is, for a string, for example, BAB, what's the time complexity to even check if it's a palindrome? Well, we'd have to scan through the entire string, right? So for any given substring, to check if it's a palindrome, it's going to take linear time complexity. So let's say n, right? Now, how many substrings do we actually have to check? N squared, because we're checking every single substring containing every single character. So to check if a string is a palindrome, we have to do a linear scan, and we have to do that for every single substring. So then that's going to mean that the overall time complexity of this brute force approach is going to be big O n cubed. So the question is, how can we do better? Well, it actually involves understanding how to actually check if a substring is a palindrome or not. For, again, let's look at BAB. We can check if it's a palindrome by starting at the outside and comparing these characters. And as long as they're equal, we'll keep going until we get to the middle, and then we'll check, and then we'll know, okay, it's a palindrome. But we could also do it another way. We could start at the middle and then expand outwards and check if it's a palindrome that way. So, well, which one of these is going to help us more? Well, let's think about this. Let's say I wanted to know, for this B, what's the longest palindrome where this B is the center of the palindrome? Well, there's no character to the left of it, so it's just going to be this character, this B itself, right? So it's just one. What about this A? Well, let's start expanding. There is a character to the left and there is a character to the right, and they happen to be equal. So the longest palindrome with this A at the center is going to be length 3, and it's going to be BAB. Notice how if we do it this way, for each character, we're going to consider it the center, and we're going to keep expanding outwards. We're going to take each character, so that's going to be n, and to expand outwards for each character, it's going to be n again. So for this way, the overall time complexity is going to be O of n squared. So that's kind of clever, right? Like a subtle difference of how we check if it's a palindrome can really improve the time complexity. But hold on, there's one edge case that we're missing. When we take one character and expand outwards from it, like for this B, we're getting palindromes that are of odd lengths. They've conveniently shown us this example where the longest palindrome is actually even. So how are we going to check even palindromes? Well, that's just a slight edge case that we can easily add to our solution. So we just have to remember to handle this edge case when we're implementing our code. Okay, so let's get to everybody's favorite part, the code. So I'm going to initialize the result as an empty string because, that's just a good default case. We'll get the longest length initially set to 0. Now we're going to go through every single character, or rather every single position in this string, considering it to be the center. So first, let's check odd length palindromes. So I'm going to have a left and right pointer. these left and right pointers are going to be initialized to I, which is our center position right now. While my left and right pointers are inbound, as well as while this is a palindrome, so I want to check that the left and right are equal to each other. Remember, we're starting in the middle and expanding outwards. So while this is the case, we know it's a palindrome, so we can potentially update our result. So we'll check that the length of this palindrome, which we can compute by saying right minus left plus 1, is greater than our current result length. Then we update the result. And we also have to not forget to update the result length. I usually forget to do this. And let's also not forget to expand our pointers outward. So our left pointer will be shifted to the left. Our right pointer will be shifted to the right. So now let's check the even length palindromes as well. Right now, you can handle this a bunch of different ways. The way I'm going to do it is setting the left pointer to I and setting the right pointer to I plus 1. So again, we're basically copy and pasting the code that we just wrote above. Maybe we could write a function to do this, but I'm too lazy to do that. So while it's a palindrome again, we'll check that the length is, we'll check that it's the longest palindrome that we've seen so far, basically. If it is, we update our result. And again, we can expand our pointers outward. And at the end, all we have to do is return our result. So I kind of made it look easy with the code, but don't let it fool you. It took me a while to write this before I started recording this. There's a lot of like edge cases that can be kind of annoying with this problem, I think. For me, putting the if statement, checking that it's the longest. Okay, so let's get to everybody's favorite part, the code. So I'm going to initialize the result as an empty string because, you know, that's just a good default case. We'll get the longest length initially set to 0. Now we're going to go through every single character, or rather every single position in this string, considering it to be the center. So first, let's check odd length palindromes. So I'm going to have a left and right pointer. These left and right pointers are going to be initialized to I, which is our center position right now. While my left and right pointers are inbound, as well as while this is a palindrome, so I want to check that the left and right are equal to each other. Remember, we're starting in the middle and expanding outwards. So while this is the case, we know it's a palindrome, so we can potentially update our result. So we'll check that the length of this palindrome, which we can compute by saying right minus left plus 1, is greater than our current result length. Then we update the result. And we also have to not forget to update the result length. I usually forget to do this. And let's also not forget to expand our pointers outward. So our left pointer will be shifted to the left. Our right pointer will be shifted to the right. So now let's check the even length palindromes as well. Right now, you can handle this a bunch of different ways. The way I'm going to do it is setting the left pointer to I and setting the right pointer to I plus 1. So again, we're basically copy and pasting the code that we just wrote above. Maybe we could write a function to do this, but I'm too lazy to do that. So while it's a palindrome again, we'll check that the length is, we'll check that it's the longest palindrome that we've seen so far, basically. If it is, we update our result. And again, we can expand our pointers outward. And at the end, all we have to do is return our result.
The new Swiffer Power Mop. Love it or your money back.
So you think you know Wix, but do you really? First up,
we're looking for the longest palindromic substring. So palindromic substring. So the start here is just return s.substring of our. It's just I accidentally did plus instead of minus because.
Result.
I don't really understand why he put it here, but the solution is not really. he put the problem under here, but doesn't give a dynamic programming solution, and it should really be under here.
When it comes to giving your bathroom a fresh spin, with Wayfair, it's easy, so you can change your
Deuce 4 was good enough to put in a raise for value on the river and somehow managed to get a better hand to fold.
She's not feeling great. I told her to chill out. She's barely slept the last 2 days, and then she's got like this expo coming up for her beauty thing that she does. She sells her and her partner have like a custom makeup bag that they sell. Raise.
Limit hold'em now.
Oh boy, the classic live tell where you tell a story, you look at your cards, you stop the story mid speech just to raise, just because you have strength. Classic. And Phil Ivey not falling for it with the 9 deuce off out of the big blind. Just note, you guys are ever playing cash and someone's in the middle of telling a story, and they look at their cards and they stop telling the story to play the hand.
Some kind of event.
They got it, just fold.
And all that stuff, but then
Just checking in on the chip
just
counts
landed
from
and
the
came straight
outer
here, and
table. It
flying
looks
kinda
like
makes you,
Hal Rotholtz is the chip leader out there with around 4 million or so. Talal Shakurchi and James Obst, about 2.5 to 3 million in their stacks. Josh Aryeh and Daniel Elahi, right around 1.2 million or so. Aryeh and Elahi are the two shortest stacks on the outer table, but still a fair amount of play. You know, they're not severely short. Aryeh was very short when he was at our feature table, but he was able to double up and then win some more chips to get a little bit healthier. So that's what's going on the outer table. Still 10 players remaining. 50K PPC here on day 4.
Got a hand here. Blind on blind. Ivy raises with the king 3 suited and Ray D in position, just decides to call with the king 10 suited. Ray flops a pair. Ivy with the backdoor nut flush draw. Limit hold'em is a game all about aggression. I've been told that you should bet until you get raised and then make a decision. Let's get the 4 of hearts on the turn for the sweat. Oh my gosh.
Look at that. Kevin Gerhardt here is a 4-time bracelet winner for a reason, because he can see the future clearly.
Calling out exactly the 4 of hearts to give Ivy the nut flush draw and the gut shot. Sometimes the perfect card just shows up. You know, until all had the 8-6 and the 7 of spades shows up.
Oh yeah.
Sometimes you just see the 4 of hearts in the deck and it appears.
Maybe enough to come along to the river.
The 5 of hearts.
Ivy backs into the flush. The nut flush 2 doesn't even need to be worried about the steel wheel because he's got the 3 of hearts in his hand.
7% on the flop is greater than 0.
That's right. Ivy leading here on the river. Rady shooting him a little.
One of the hardest problems in Leetcode contests, it's called find all good strings. The solution is a DP with KMP, Knut Morris Pratch. You can see the yesterday's stream to see the solution live. And when I finished, I wondered I mean, the running time was in the low percentile of Python. When I was expecting this to be pretty fast, so I started to investigate, and I found I looked into the top submissions, the fastest submissions, Python submissions, and I found this one, which it's doing the same thing, the same algorithm, but it ran in like half a second. Mine was taking 1 second, and I didn't know why. I tried a few things and I couldn't figure it out, but later I thought about it and I realized that sometimes there's an advantage. I mean, in general, it's usually faster to implement DP bottom up with arrays, especially in Python, because recursion is usually slow in Python, but there are exceptions, because sometimes with memoization you only solve the sub problems that are necessary for the answer of the problem, and in this problem there are many sub problems that are invalid, that cannot be reached, because for example you could have, since you have
Ivy hasn't moved this entire time, over 3 minutes, and he has not moved at all. His facial expression has not changed. He's just deadpan staring into space. Do you think there's a time where Ivy calls the clock on his opponents?
I was just going to ask, is anyone going to call the clock? Like, it doesn't necessarily have to be Ivy. It could be Tong. He does fold.
He does fold. 3 minutes and 40 seconds.
I'm going to go out on a limb and say that's going to be the longest tank we're going to see today.
I think so too. I think so too. He ended up with the right decision. Impressive.
Ivy chipping up there nicely. He's up over 4 million now, or back over 4 million. Ray D, 1.71 million in his stack. Ray D is the shortest stack at this table.
It really is impressive to see players making folds like that. Understanding that saving chips, especially in this part of the tournament, is so worth it.
I'm guessing a cash game, Ray D probably just flicks in the call.
Yeah, I don't think it takes more than 3 seconds. He just flicks it in.
You got it. Here you go. Ray D and Phil Ivey have a lot of experience in cash game, probably a ton of experience playing with each other at insane limits.
I love when people say, "Oh, you play that big mix game at Resorts World, like 8160." No, that's not big.
Yeah, these guys are playing what, 2K, 4K, 3K, 6K.
Yeah, 4K, 8K.
Just you said you were gonna go straight to bed, knock out. Did it work out?
Yeah, I mean, I didn't get home till whatever, like 2:30 or something like that.
I think it's kind of hard to be up and ready and fresh by 1. Come back here personally. Obviously, you were late again, so yeah, it was for you.
Yeah, the turnaround time is not
pretty quick.
It's
Because I can't get to bed. I can't really get down
to
to like 4:30.
Yeah, normally between days you have a 12-hour window from when you get to leave to when you have to be back. And some of the times, with all your adrenaline going, sometimes you got to get food. it's not easy to fall asleep in that time frame to get a full 7 or 8 hours of sleep.
Yeah, I think that that's one thing that is underestimated in tournament poker. That, you know, they usually do a really good job of giving you 12 hours of sleep. Even myself, after I play a full day and you have to come back for the next day, you know you're driving home, you're like, okay, I got to be back in 11, 12 hours, not a big deal. But then you get home, you're still so hyped up on playing all day that it's like you need another hour or two just to fall asleep. I usually go home and I'll just sit on my couch for like an hour or two scrolling through my phone until I get tired.
Right.
Because I have so much adrenaline still pumping through me. And you're also really excited usually when you bag. You're like, okay, I made it through. Like, I made it to the next day. We're close to the money, or we're in the money, like that sort of stuff. So that I can only imagine what that sort of feeling is like, say, in like the main event. Because it's like every day you get closer and closer to this insane goal. I mean, that just must be crazy.
Yeah, I don't know about you, but every time I bag up a tournament, which hasn't happened much this summer, but I go home and I replay so many hands in my mind to see if I made any mistakes, to see if I can make any different decisions, to see, like the other night when I busted out, I missed a spot where I should have just bluffed off all my chips because I think it would have worked, but I wanted to preserve my tournament life in the moment and decided that I could take a better spot, and a better spot did not come to fruition, and I ended up making the wrong play at the wrong time and regretted it afterwards.
I've done less of that myself in probably the last year, and my reasoning behind it is that I've been trying to value the rest within the tournament. So at times I've done what you've done. I've gone back, I've replayed hands, and I'll be up for like 2 or 3 hours, and I'm like, what am I doing? I need to sleep.
Yeah.
And then now I'm just like, you know what? I'm just going to play in the moment, and I'm going to figure it out, and I'll do my studying like pre-tournament, my studying post-tournament, whatever. But like in the actual tournament, I just don't want to be bothered about that sort of stuff.
I wish I could shut the voices off.
I mean, listen, it wasn't easy. It took a lot of work because you want to like study all the time. And another thing is like even like on breaks, you want to talk about hands with your friends. You want to replay things. Like now I'm like, I just want to go for a walk on the break. And like I don't want to be talked to by anyone, you know. But it's obviously easy to like run into someone and be like, hey, can I tell you about this hand, or you tell me about it, you know.
Right.
So I actually got that from ODB, David Baker. You know, he does more of that now where it's kind of just like in the moment, just let me play, and I'll figure out stuff before or after.
Yeah.
Did you
Ivy here with 2 4s.
6 hours maybe. Yeah. But worse than the night before.
These small pairs always tricky to play in limit hold'em.
Tonight we hopefully should get more time. If you're one of the final 5.
It's weird. At home with my kids, I actually don't get that much sleep, but it's something about playing cards makes me more tired than doing stuff at home.
It's draining. Passed out of the big blind after semi-bluff raising the last hand on the turn and taking it down with a very similar holding of King 10 against Phil Ivy's 4-4. We're off to the races. One side is much favored now compared to the other side. After Phil Ivy flops middle set, basically the best flop he could ask for. I expect Ras to call once for a small bet with 2 overs. It's hard to make a pair in this game. It's even harder to make 3 of a kind. A lot of these mixed games come down to making the right decision on the turn. That's when the bets become bigger. That's when you can put more pressure on your opponent, especially in PLO. PLO equity denial on the turn is paramount. Ivy continuing on the turn with 100% equity in this hand, cannot lose unless by some miracle he finds a fold. I think Brian Ras is going to just give it up here. Nice hand, standard, take it down.
Last hand now of Limit Hold'em before we move on. As a reminder, 9 games in this rotation. You have the standard horse games. Then you have No Limit Hold'em, Pot Limit Omaha, No Limit Deuces 7 single draw, and Limit Deuces, or sorry, yeah, No Limit Deuces 7 single draw and Limit Deuces 7 triple draw.
Raise. No, big blind. Sorry.
We got a word out of Ivy.
There you go. Yeah, well, because he had to correct
Correct
the
the
action
dealer,
there.
yeah.
Ivy is in the big blind here. He did not raise under the gun in the big blind, so making sure the other players know what's happening. Folds to Rast in the small blind. He's got 10-5 of diamonds.
Don't think fold is an option. I think raise or call. Probably what's going to happen here. Does decide that aggression is the best course of action, which is true for most of the time in Limit Hold'em. Heads up to a flop with Phil Ivy in the lead with the overs. No heart in either player's hand. Rast outflops Ivy.
Rast will continue here. Ivy's going to come along.
Sure.
Not a believer just yet.
2 overs, backdoor straight draw. Interesting check here from Rasp. Maybe he thinks Ivy's calling with a 7 or has some sort of heart equity. Maybe trying to pot control this a little bit.
Yeah, probably just checking just to check call. I can't imagine he's check folding.
Check fold is never an option. It's either check call or check raise. If Rasp thinks that his pair with a bad kicker is good, he could go for a very thin check raise. But it looks like Rast is just going to check call this bet and try to get his hand to showdown. Ivy needs a queen or a jack on the river to win this pot. That's an interesting card because Ivy's jack now blocks the nut straight, so expect Rast to check, and Ivy may or may not fire, try to take down this pot. Knows that queen high probably isn't good at this point and is just going to get snapped off by Rast with his pair.
Ivy just with the little point over to Rast's hand, signifying that Rast has the winner if he's calling there.
Yeah. Ivy can't beat anything if he's betting queen high and getting snap called.
Double 20. 20, 40, 60?
Through all my hours of commentary of this game in particular, we've only seen one person try to bluff, stand pat as a bluff, and that was Dmitry Urbanovich yesterday. That's what I look for in this game. I want to see poker being played. I want you to look into someone's soul and say, you don't got it. I'm going to try and win this hand with aggression.
This is my favorite poker game to play, No Limit Deuces 7 single draw.
It is very fun.
I just think it's so pure.
Yes.
There's only 2 betting streets. Like it's one of those games where I feel like you can just really just like kind of look at your opponent and be like, you either have it or you don't, like type of thing, you know?
Right. And that's what I look for too, especially from the best players in the world. This is also one of my favorite games. I'm not the best at it, but it's one of my favorite games. Can't wait for the 1500 version.
It's great to watch the best in the world play this game. You know, I think of Billy Baxter, I think of Nick Schulman.
Billy Baxter might be the greatest of all time.
Yeah.
I mean, don't know the rest of Phil Ivey's hand, but he's raised it up 3x at this point, and Dekargani has a very monstrous 1 draw to an 8.
And you have to come in with a raise in this game?
Not anymore.
Not anymore? Not anymore?
They
Okay.
changed it this year, which is great. We actually saw a couple limps yesterday, especially from Johnny Becker.
Good, I like that. Johnny Becker, another one who's incredible at this
Incredible.
game. You know.
Absolutely incredible. I mean, Benny Glazer, also one of the greats in this game.
I'm gonna guess that these two guys, Ivy and Dekargani, are also very good at this game.
Yeah, I assume these are included in their cash game mixes. Farzad Banyadi.
Guessing you'll see a raise here from Ray D.
I would like to see a raise. You're in position. You have a very good draw. You could just take the pot down now.
All of it.
All
Look at that.
in.
And Ivy just looks right at him.
Ooh. Says let's play for it all. Come on, Phil, put your cards back on the reader for us, please. We need to know, especially if you're considering this. We need to know.
I mean, I think Ivy's got a decision here. I think if he would have had just a bad hand, it would have gone quicker into the muck.
Yeah.
Little too rich for Mr. Ivy's blood, and Ray D takes that one down.
6-5-3 deuce deuce. It really was
Wow.
a tough decision.
Wow.
Ray D said, all right, there's 180 out there. I want it all right now.
Phil Ivy probably calls there if that 6 is a 7.
I might think that he would gamble with a 6 instead of, or with a 7 instead of a straight draw with a 6. Especially
Yeah, the reason that I brought that one up for everyone out there is because Ivy's hand, if he were to toss the deuce there, a 4 kills his hand, renders it basically dead because he would have made a 6-high straight.
Right.
Straights and flushes in this game, no bueno. You don't want them.
Rast will open this hand. He's got an okay 1 draw to a 10-8.
For those of you wondering, no limit deuce to 7 single draw players are dealt 5 cards. There is 1 drawing round. You are trying to make the best low card hand, but aces are high. The best hand that you can make, because straights and flushes do count against you, is deuce 3, 4, 5, 7, but not 1 suit. You don't want it all in spades.
Ashton out of the big blind with the 9-7 draw. And these players are quite deep. Raz started the hand with 3.4 million chips. Expect just a call here and a draw one, and see what happens.
Ashton drawing 1, Rast also drawing 1. Ashton improves to a queen 9. Rast getting an ace. Remember, aces are high in this game, so. Does Rast need to bet his hand in position here?
I think he checks.
He does check
most of
behind.
the time. He beats all pairs. Yeah, you can turn your hand into a bluff. It's not really necessary. One thing I will say about this game, on this table, it's better for the players. As we saw yesterday, the players are complaining that they're playing with the small face cards on the feature table, and they have the large cards on the outer table for the stud variants.
Okay.
So every level, you have to switch and retrain your eyes and your mind to get used to the different cards. In this game in particular, you get to side sweat cards much more easily than you do with the big face cards on the outer table. And we saw yesterday Marco Johnson hard sweating a card on the river against Phil Ivey in Raz, where Ivey improves and Johnson needs a 2, 4, or 5 to stay alive in the tournament, and he sweats the side and goes 50-50, knowing that it's either the 2 of spades or the 3 of spades, and then slowly peels away to see if there's the extra pip in the middle of the card. Finds the 2 to stay alive. Phil Ivey was not happy about that. So some people think it's a slow roll, but if you're all in for your tournament life,
I like when they make them, or when they allow them to sweat it out.
Yeah, definitely.
They even let, on the bubble of the 10K limit hold'em, they let Eric Wasserson sweat the river card.
The river card, yeah.
You know, like stuff like that. I mean,
Right.
in the 10K plus events where it's more of a cash game environment, like feel to it, then let the guys sweat the cards. I mean, whatever.
Right.
It's fun to watch.
Agreed.
I do have some news from the outer table. We have lost Daniel Elahi.
Oh, wow.
In 10th place. No limit hold'em. Daniel Elahi clashed with Talal Shakurchi. Or sorry, yeah, Talal Shakurchi. Elahi was all in with ace king against Shakurchi's pocket 9s. Queen 8, 6, 6, 6 was the runout, and the 5-time gold bracelet winner, Mr. Daniel Elahi, hits the rail, 10th place, $115,000 for his prize. That means everyone left, 9 players. There are 4 on the outer table. There are 5 at this table.
What's up, buddy?
Everyone left is guaranteed $141,000.
Good run.
Nice.
It was a
Good luck.
pleasure watching him play.
Yeah, Daniel Elahi doesn't play a ton of tournaments these days, but he does come out. Left is guaranteed $141,000. The outer table, there are 5 prize. He hits against Shakurchi plays from the outer.
Right.
No limit hold'em. In the 10 to it. Then
wow.
Talal against Shakurchi. Or sorry, yeah, Talal Shakurchi. Elahi was all in with ace king against Shakurchi's pocket 9s. Queen 8, 6, 6, 6 was the runout, and the 5s for his 5 at this table.
What's up, buddy?
Yeah, Daniel Elahi doesn't play a ton of tournaments these days, but he does come. Then you'll PL him, so 50.
Button with a 2 8 8 6 4. Matt Ashton out of position, just calls with his pat 10 8 6 3 deuce. Decides to break the 10, which is normally an okay hand to get to showdown with. He could have 3-bet and stayed pat, or he could have called pat. He decided to call and break the 10 to try and improve his hand. He drew 1. Ray D contemplated staying pat as a bluff, and now has drawn 2 to make a king low. Matt Ashton bets 100,000 into 300,000 after the draw, out of position, after pairing his 6 against a 2 draw, knowing that the 2 draw is very unlikely to improve to make a really strong hand. Now the action is on Ray D with his king low, trying to make a decision for 100,000 chips. The only hands he beats are pairs or an ace. So we'll see what Ray D decides to come with. We are over a minute on his decision clock this far, so maybe we'll reach the 3.5 minute mark.
Yeah, I mean, maybe I was lying earlier when I said that that would be the longest tank when it was the limit hold'em hand against Ivy. I will say, very interesting to see how Matthew Ashton played this hand. I would have agreed with you that he would have maybe just called or 3-bet and then stood pat with the 10, but Ashton taking a different line.
Right, he understands how important position is in this game in particular, and being out of position, you want to try and draw to make the best hand. Maybe he gives Ray D more credit for being tighter and having a 1 draw himself, and Ray D does flick in the call with the king, correctly identifying that Matt Ashton could have made a pair, and it did. So great call. We have seen Ray D take a little bit more time than most players in these spots, but has ultimately come to the correct decision multiple times.
Ray D, of course, an absolute legend in poker. I'd say mostly known for his high-stakes cash game prowess. He is a bracelet winner. He won the 10K Raz Championship back in 2016 for his only gold bracelet, but just because he doesn't have multiple gold bracelets doesn't mean he doesn't have the experience or the skill to battle with these guys in this field. He's one of the best mixed game players in the world. Ivy here, very pretty looking.
Yeah, drawing to a 7 is always a great sign to see in no limit single draw. Ray D having a pat 10 at this point in position of Ivy could go multiple ways, just like we saw Matt Ashton. Being in position versus out of position in this scenario could create a very different dynamic. We could see a 3-bet, and then when Ivy draws 1, we pat. This is also what we like to call a convertible 10, where if Ivy pats in front of us, we can make the decision to break our 10 and try and draw to
take the top off.
A very good 8-7. You know, that's not a straight draw. So all options on the table except for fold here from Ray D. Let's see what he comes with.
MBTY, very good point. The only reason Ray D doesn't have more bracelets is because he doesn't play that many tournaments. I mean, yeah, you can certainly put him in that category.
Can't win when you don't play. Rast with a nice looking hand out of the big blind here. I expect him to just call out of position against 2 great players. I will say that Rast acts very quickly. He does not go into the tank very often.
9 people now.
Rast gonna draw 1 here. Ivy gonna do the same.
And now the decision is on Ray D with his pat 10-8, which is a favorite against all 1 draws. But if 2 people are drawing 1, your equity pretty massively decreases.
He is pat though. Rast here pairing his 6. Ivy here still keeping his card away from the reader.
We did get word that Ivy has picked up the 4 of diamonds to give him a 7 low, to give him number 4, the 4th best hand possible, and Ivy goes with the overpot bet after the draw with the 4th best hand possible. He could be very comfortable knowing that he has the best hand in this spot. Now the action is back on Ray D. We'll see how long the decision timer ticks for this one.
Listen, I'm not one to get live reads off Ivy, but he looked very comfortable there. He looked at his hand, didn't think too quickly, just casually threw the chips out.
Well, when we know he catches the gin card for him. Ray D actually only took about 10 seconds to flick in the call.
What did you catch, Brad? 6. It actually paired me. Thank goodness.
So Ray D now going in hindsight mode, which poker players are notorious for. If he 3-bets, he knows that Ivy is going to catch a 6, which pairs him and gives Ray D this winning hand at showdown.
Yeah, because that would have, the 3-bet would have most likely forced Brian Rast to just fold his hand.
Yes.
Ivy would have been in there.
After the back call, I was like, please let this fucking pair me, Jesus. No, now I don't have to think. All right.
So it seems that Rast side-sweated a 3 across, which is amazing for his hand because it's either a 6, 7, or 8, and he has a 6 in his hand. So 2/3 of the time, he's going to improve his hand. But he decided to check and let one of the other 2 players bet. So if he does improve to a 9-8 or a 9-7, he's put in a very tough decision after it goes bet call.
Make the final table in event number 55. People will pick yes or no.
Okay.
And there's like a series, each contest will have a series of like, let's say 15 to 20 questions.
Okay.
And then whoever gets the most right would finish in first place on that contest leaderboard and win the prize.
I like it.
You know, we can say like, if it's no limit hold'em, it's a lot easier. It's oftentimes, so we'll be like, you know, at the final table, what will the color of the first flop be? All red, all black, 2 red, 2 black,
Sure.
something like that.
Yeah.
How many hands will the final table take?
Okay.
Stuff like that. We did have some contests that were specific to like Daniel Negreanu, for example, saying like, you know, how much money will he win this week or that week. And we have some contests specific to the main event, like how many entries will it have, who will finish further, Phil Hellmuth or Daniel Negreanu, stuff like that. So yeah, just a whole bunch of random questions that we can kind of come up with.
I like it. James Opes with a hammer lock on this hand, just going to take it down with his made 7 low in 5th against a king 10 low from Rod Holes.
It'll feel good for Ops to rake in a pot. Feels like he's been a little bit quiet.
A little bit. We've seen him over the 3 million chip mark, drop down to about 2 million at this point.
On the outer table, Matthew Ashton is over there. He was just moved from this table. We also have Phil Ivey on that outer table, Brian Rast, Christopher Tong, and Ray D, Ray Decargani. Those are the 5 players on the outer table.
REA picks up a premium here with 6-4-3.
Yeah, something he'll very much like to see right now.
2 people behind him have aces up, but he got no action. He's very happy to take down this pot, pick up 100K for free. Sarcastically saying, let's play this again with how many chips he's lost in this orbit.
Ross the boss, man. Listen, I can't help the people. If they don't understand things are on a delay, they don't understand things are on a delay.
Through the magic of the internet, we can bring you shortened delays.
Yeah, and the delay is for gaming purposes. It can't be in real time because that could open things up to some mishaps that you certainly need to avoid.
That may or may not have already happened in the past.
Yeah, exactly.
Shakurchi completing here with a 6 and a 10-4 down. James Opes with a 9 up is a non-believer. We have a fair fight going to 4th Street.
You guys can see the equities there on the screen, 58% to 42%, now changing in favor of Shakurchi.
And the hand is now over. Shakurchi can credibly represent a strong holding to go with his 6-5 up. All right, this is Josh REA's favorite game. May not be his best game as a self-proclaimed limit hold'em specialist, but we'll see if he can get it in and run it up in a game that I know he runs pretty well in.
15, 30, 30.
PLO is the game right now. Probably a game those of you out there watching are a little bit more familiar with, but if you aren't, 4 cards dealt to each player. This game is high only. You have to play 2 cards from your hand. You can only play 2 cards from your hand. Trying to make the best possible 5-card hand. Flop, turn, and river, just like no limit hold'em. Betting betting action on all the streets, pre-flop, flop, turn, and river.
And one thing to note, Josh REA in Raz only had 3 big bets, but switching the game to PLO, he now has 11 big blinds, which is much more stack to navigate with.
Oh yes.
It would take at least 2 raises for him to get all in with his current stack size. The Queen 9-3 deuce Badoogie not going to do it for him.
Lahi looking interested here from the big blind. Ace 8, 7, 6, 2 suits.
Where are they going?
This is a really good candidate as a 3-bet bluff, and he does opt to go for it. I really like this play. Put a lot of pressure on James Opes.
Daniel Lahi feels like one of the absolute best at PLO. Lahi is a 5-time bracelet winner, 2 in PLO.
So many of the 5 times, I guess I got to step my game up.
Just got to be luckier than everyone else. Doesn't matter how good you are.
I've proven that I'm luckier than a lot of people multiple times. Interesting flop here. A lot of flops to the bottom end of the straight. James opes with an open ender to the top end of the straight, and a pair, and a flush draw, with more equity at this point. We'll see how these players decide to navigate. Check, check on the flop. That's the gin turn card. Opes cannot lose this hand now unless he somehow manages to fold the king high flush.
Hey programmers, Alvin here. Right now let's go over the approach for this max palin subsequence problem. So in this problem, what we want to do is take in a string and return the longest subsequence of this string that is also a palindrome. And so what a subsequence is in the context of this problem is some string I can obtain by deleting some characters of our original string. So for example, what would be the answer for this particular input? Well, I can delete any characters within this string, but I have to keep the relative order of characters the same. So let's say I deleted the X. That would give me LUUL, which is indeed a palindrome. Recall that a palindrome is just a string that's the same forwards and backwards, and this would actually be the longest palindrome I can form as a subsequence. Since this length is 4, I would want to return 4 as my final answer. So in short, what we want to do is return the length of the longest palindrome we can make that's also a subsequence, bearing in mind that a subsequence can be generated by removing any characters we want from the original string. Let's take a look at another example here. If I was given this string, to form the longest palindrome, what I could do is delete the T and the D. Deleting those two characters would give me SOS, which has a length of 3. That would be the longest palindrome that is also a subsequence. We can take a look at a trivial example as well, and this will help us design our code. Let's say I only gave you a string with a single character inside. Well, trivially, this character is itself its own subsequence, and it's also a palindrome. We can always treat something of one length as a palindrome, and so we should return 1 in this instance. So let's come up with a strategy for this one. We'll step through the example of LXUUL. In the long run, we know that the answer we should get is 4. We know that this problem basically has us decide over which characters to delete, if any, to form a subsequence. So what I'm going to do is draw the decision tree that I can take as I make those different options. So we'll start with our original string at the root. Now that I have the string, what I want to do is consider any palindromic characters that I can match right now. To do this simply, what I could do is just look at probably values, because I know in this problem I'm interested in the longest
Can I do the same with what I was doing? Can I do the same? Can I do... There's... BABA is 1, and BAB is another. Or BAB is 1 and ABA. That's it. Right? And then you remove, and then you look and you see, okay. There is, okay. And you have B. Let's see, maybe we can do another one.
Palindromic subsequence, and so I want some max value logic. In this case, there was a 2, I removed the last character, giving me just 4. Consider any palindromic characters that I can match right now. To do this simply, what I could do is just look at the first and last characters of my current string. In this particular scenario, I see I have an L at the front and an L at the rear, so what I can do is actually match these up. If I match them up, then I should actually cut them off of my next string. So I should transition here to just XUU, and the logic being that I have a match at my front and my back, so I can remove both of those characters. And I know in the long run, I want to return the length of the longest palindromic subsequence, and so I'm going to need to remember how many characters I just matched here. I matched 2 characters, so I'm going to label that number along the edge. Let's continue this pattern. Now we're at the XUU node. What I can do once again is try to consider any palindromic characters. What I should do is look at the first character of X and the last character of U. Unfortunately, they don't match, right? So I have to do different logic here. Since they don't match, what I need to do is branch. Along my left branch, what I can do is just remove the first character. So if I remove the X, I end up with UU, and I'm going to label this edge with the number 0 to indicate that we did not score any match. But I should have also branched by removing just the last character. So if I remove the last U, I would have ended up with XU. And again,
Thing is, how do I, if, let's say it's BAB, and I remove the first 2,
Again, I label this with 0 because I didn't perform any match. Now from here, I just apply the same algorithm recursively. Let's say we were evaluating that left node and want to expand it. If I look at the first and last characters of this string, I have u versus u, they totally match, and so I should remove both of them. I should label the edge with 2. And when I do that removal of both of my u's, I actually end up with an empty string as a leaf, and that will probably translate into a base case. Let's continue expanding the right-hand side. So for the xu, I can consider my first and last characters, so x versus u. They are a mismatch, so I need to branch twice, right? In one scenario, I remove the first character, so if I remove x, I end up with u. In the other branch, I remove the last character, giving me just x. And again, I label the edges here with 2 zeros to represent the fact that I did not score any match. I think this would be the full decision tree that we need. So somewhere hidden in this tree, we actually have the answer of 4. What we'll want to do is maybe lay out some explicit base cases here. We know that our leaves terminate in relatively small strings, and I have 2 cases here. So let's say we considered those base cases. Let's say we had a string whose length is 0. Well, then we should also return 0. And what's the reasoning behind that? Well, if I gave you an empty string and I asked you what's the longest palindromic subsequence in the empty string, well, it's going to be 0, right? Because you have no characters to consider. So I'll jot down that 0 wherever I have empty nodes in my tree. But we need another base case. Like we said at the start, if we were given a string that contains exactly 1 character, so its length is 1, then we should return 1 because that entire string is trivially its own palindromic subsequence. So for all of my nodes that contain just a single character, the base case for them is also going to be to return 1. And from this point, I can use some logic to reconstruct my higher level solutions. So let's evaluate this left-hand side. I know that the 0 is going to return to its parent. What I should also do is add the value along the edge. So there was a 2 along the edge. So I do 0 plus 2, giving me 2. If I do a quick spot check, this makes sense because I have an answer of 2 above the UU node, which tells me that, hey, the longest palindromic subsequence given UU is of length 2, right? It's the entire string itself. Let's evaluate some of this right-hand tree now. And so I know that these 1s are going to return upward. And because I have 0s along the edges, I don't increase them. But now this XU node has a decision to make. What it should try to do is choose the bigger between the 2 values. Because I know in this problem, I'm interested in the longest palindromic subsequence. And so I want some max value logic. In this case, though, I have a tie, right? 1 versus 1, so I can just return a 1 over here. I'll carry this logic further. So I return both of these. And now I choose the larger between the 2, just giving me a 2. Bear in mind in this scenario, since I have 0s along the edges, I don't increment this value. We do one more return upward. Since there was a 2 along the edge, I do 2 plus.
I mean, can we do like if it's equal, do we branch? We do 1 and we have 2.
Store each of those substrings as keys of our memo. Strategy as the size of the input scales. So if I just use this simple example of A, B, D, E, F, if we carry over the algorithm, eventually we're going to see some duplicate nodes. If you look at this example, it's a good one because it signifies the worst case, right? I have no matching characters here. And like we said previously, if you have mismatching characters, then you have to branch twice. So an example like this would give me the maximal branching factor. So let's say we drew out a few levels of the tree for this. Remember that when we branch to the left, we're going to remove the first character. When we branch to the right, we're going to remove the last character. At this level of the tree, we already start to see some overlapping subproblems. I can look at these nodes of BDE, right? Since they're duplicate nodes, they're duplicate inputs, I should be able to save their results to reuse them later on. In other words, the subtrees rooted at BDE would be identical. And of course, as I made my tree larger and larger, I would have more and more overlapping subproblems. So that means we're going to use our classic memoization strategy. So if we say that S is the length of the string here, what can we say about the complexity?
And I guess I could do the same. So let's try these two. For this one, you just remove the outside. But then again, I don't know. Okay, let's just remove them just to start off. You remove the outside, and then you remove left and remove right. Remove left and remove right. But now you remove right, remove left, remove right. Or they're both equal, and then you get nothing. And both equal, and then you get nothing. Let me do this for nothing. Wait, where can I shorten this? Regardless of warnings, the future doesn't scare me at all. Nothing's like before. Okay, so you got two base cases. You either end up with this or you end up move left, right, or remove both. Right? Until you reach the base cases. Maybe it's the same here. Move left, right. Here it's this. ABA or ABAD. Yeah, ABAD.
Like last.
So B ABAD or BABA. So Baba or Abad, and then again, both of them are not. Both of them are not. Do it again. ABA. AB. AB, and then we go to stop at B. A. This would be B. B, A, D. B, A. What? B, A. B, A, A, B. B. A. So we have this, and what we do is we remove we're either removing the left, the right, or removing just one, or moving both. So we're either making two recursive calls or just one. So There's repeating here, here, here. We're here and here. Go downstairs. Go lay down. So, can I create a recursive function that removes the left or the right, or if they're not even, the first and last character not even, remove the left and the right, and keep going until you reach one character. And if you reach one character, then you add that character or do you just not even go down? Yeah. You add that character. That character to a list. And only when you come up from the single one do you and return. Let's try a race car, maybe. Let's try like bye bye. Cada día, cada noche deseándote, para hundirme tus abismos inventándote. Maybe we just do this. Para hundirme tus abismos inventándote. Deseándome en la farsa de los labios, saboreándome, saboreándonos. Deseándote cada día, cada noche, deseándote, mujer, cada día, cada noche, cada día, cada noche. Deseándote cada día, cada noche. Estás a solos cada día, cada noche. Disfrutándote. Let's just do the. Maybe instead of doing that, set true or false. Sono con lei pensando en ti. Los ojos y pienso en ti. This doesn't really pass up anything. This doesn't really pass up anything. Pass up anything. I can never love again.
unit squares in this place, one here and one here. That's why the answer is 6. The constraints are there are 2 to the 10 to the 4, so 20,000 numbers, and the heights are up to 10 to the 5. So we are thinking about the contribution of every value. You mean like the how much water you're gonna have in this position, for example, and that is going to depend on what? On the maximum to the left and the maximum to the right. Avoid complexity on special cases like T-shaped water. T-shaped like this. Oh. Well, like the middle element of example 1, the middle pool. But what do you think about? I mean, if you want to know how much water, what's the height of the water here? You want to know the maximum to the left and the maximum to the right? No?